Hi. Nick, are you still there? I don't know if you got the last message. That's so annoying. This week is the vacation week, and on 10th August is the starting point of the project. 10th August. And the plan is to do transmission line stuff and reflection and radiation stuff, and maybe before that the basics, because it's some I don't want to do the basics, but I think I have to because I'm too far away from all the stuff. Yeah, let's see. So this is very strange that we have yes, a man get line. I think I will do C file check end of file. Detecting end of file in C. FEOF. FEOF of standard in. The strange thing is that, oh, okay, that looks better. If I press Ctrl C now, that's strange. Oh, that's so mixed and bad, but okay, let's see. I've pressed Ctrl C and I should see what? Some index in between and 3 lines. Yes, that's a good idea. Now I should see. Now we see what this thing is doing. Why do we see only one line? Okay, we should be in the main still. Strange. Okay, it's executed all the time. That's fine. But get line. Do we get? Do we have? Yes, we have AB AB. But then. That's interesting. Yes, we always. Okay, it's working like that. No, what? I should use. I should not mix it. I should not mix it. It's such a bad idea. Okay, let's do the normal way. Okay, char pointer p data, and then we have a get line size t num bytes num read, and then we have get line. Pointer to is a pointer p data. Yes, and then we have a pointer to num read. Fine. So, and we have yes. the return value on success, get line. Get delim, return the number of characters read including the delimiter character but not including s size t. Numeric s size t res. Data num res. Okay. Line. We remove the whole line stuff. We say res is get line. Stop. Res is gleich get line, and then we say on success some number of that including the null word. Return the number of characters read including the delimiter character, but not including the terminating null byte. This value may be used to handle embedded null bytes in the line read. Okay, both functions return -1 on failure to read a line, including end of file. Inval. Yes, okay, no memory. Yes, okay, let's see. If res smaller than 0, then we say return could not read line from standard input. We have to free the p data in any case. That's okay. If log requested, yes, fine. And here we have to consume the stuff. If not res, then break. I could not read from standard input as d. As the error, hopefully we don't have, this stream is unstable, hopefully it's working now. Error number. So I want to see what we get here. P data, this is allocating stuff and is telling us how many bytes we have read. So, and we get the complete line, it seems. Okay, line. But that's not bad argument. In the event of a failure, error number is set to indicate the error. If was set to null before the call, then the buffer should be freed by the user even on failure. Both functions return -1 on failure to read a line, including end of file condition. But here we don't have an end of file condition. Interesting. That's strange. Okay. Okay, res. Here we have p data. P data. What is happening now? No matching function call to get line. It's in stdio. stdio. Ah, yes, standard in. We read from standard input. Free invalid pointer. Ah, interesting. We consume the pointer here and we have to free it in at this. A B. C. Let's check. Let's check our tests. No. Unit test. File standard IO providing. I think here we have this something similar. Get line, yes. This is working flawlessly. So we have numBuff, numRead. Oh, that's good. That's good. We call it like that. Remove this and here. Okay, we have numBuff and numRead. And pbuff, numBuff, numRead. Okay. pbuffer. So numRead. Res is numRead. And then numRead is numBuff. Do we need this numBuff here anywhere? I don't think so. No. Okay. Numlines. Okay. numRead removed. Buff, numBuff, numRead. Okay, now we in this case it's completely different. This thing says if not read then break. Only if numRead is smaller than 0 then return positive. That's interesting. Could not read line, yes. Ah, yes, because in case of failure we have to free the buffer, but not if we don't get any bytes. Yes, that's it. That's it. Okay, so including EOF, then we don't have EOF. Yes. Let's see what is happening here. Oh, come on, stop. Stop, come on. Warning log could not read line from standard input. Yes, because end of file, hopefully. We save the log. If this is up there. Yes, that's way better. That looks good. Because now, yes, way better. This is the part we do all the time. This is a wall. We try to get something. If we didn't read anything, that return, then return. Get line return value. That's bad description because there should be a 0 return value as well for non-blocking files. So if we did not get anything, then just break. If we have an error, then check why we got an error and then save the log. And otherwise, if we got something, then consume the stuff and free the buffer in the error case and in the good case, but not in the pending case. That's it, hopefully. Oh, come on. I'm missing here something here again. Invalid pointer. What is happening? Because I'm stupid. I'm so stupid. Okay, yes. But yes, because I have initialized this. Yes. We should always initialize that stuff. pbuff is equal to null. That's bad. Even in the other application, numbuff is equal to 0 as well. That makes sense. Could not read line from standard in resource temporarily unavailable. Yes, this. What? Okay. Let's do something again. Proc inf log OEA AAA, okay. That's working. A line is P string and pbuff. This application takes way too long. Index 0 with the error, with the new line. We don't want the new line, so we are removing the new line. That is pbuff num read is 0, and then we say minus num read. So I remove this new line here. Yes, that's fine. And then if resource temporarily unavailable, that's interesting. A free if we have. So if error number is equal to then we make we just make a break. Linux error codes. Come on. E again. Yes, that's E again. That's exactly what I want. If we get an error, then we free the buffer. If it's just E again, then can we do this? That would be interesting. Okay, we have now we have the same behavior as before. So as you can see, we can have a lot of interrupted system call. We can have multiple error codes, and these error codes are not documented in this page. That's bad. Okay, but whatever. So let's do this. A. Yes, this is fine, but oh, okay, this is fine too. Okay, so that means we have to be in here, but all the time. That's strange. Error number. Yes, 11, 11 all the time. As you can see, we get C all the time. Always the same error. Resource temporarily unavailable. Let's try something. The examples and then log catching and then test. Test 1. Okay. Test 2. Grab this and then output. Yes. And if we say test sh standard IO, index 1, index 0, index 1. So this application is working as expected. Maybe I was not patient enough. No, it's completely the same. Now it's strange. Now it's completely strange again. This is the application that is working. Ah, yes, okay. We did not set the blocking. Ooh. Maybe can we clear the error somehow? I think we should see clear error. No. No, there is no need to reset error before calling the function because the contract reads the opening functions return a pointer. Test the return value and only log it when you actually have an error. The easiest solution would be to make it blocking, but I don't want to. Even if it's a very simple application where we could make it blocking. But I don't want to. If now amp path -1 is equal to this, then remove it. Can we clear this thing? Does this make sense? Looks strange to me. Could not read line from standard in success. Okay. Could not read line. Yes, it's E again. Ooh, but that's interesting. That is interesting. Because yes, this thing is not changing error number again. We have to reset. Standard in reset error. What? I have the following program. Code as explained, the program will not work probably because at line 1, when the user was entered, it will leave in the buffer 2 characters. First, why doesn't the second get jump? Clearing input buffer. No, I don't want to flush this. If I get one... No. It's so bad. That's so bad because... Actually, that is really bad. Okay, let's try this. Let's try this thing. Now it should work. Completely as expected. Yes, 1, 2, 3. So yes, that makes sense. Okay, so if I now if I press Control C, could not read line from standard in, no such file or directory. That's interesting. Okay. Now we should have log catching. We should have a lot of logs. And the last log has the last 3 entries, 7, 8, 9. So that's perfect. Yes, fine. And then I want to send a signal. I want to send a signal. Unit tests, stdio sig user to log catching. Kill all. Log catching. I want to make p is equal to pdof log catching. That's better, I think. And then we say kill. And then p. If set p, then exit 1. Otherwise kill this thing. Sig user. Echo log catching not found. Not running. Log catching not running, that's fine. Okay. Now I want to execute the file again. This was our last log. We don't get any log at the moment because it's running fine. Now we say sig user. And we should have a new log. And that is, the new log is called user. And we can make many requests. Perfect. Fine. Okay, and then if we press Control C, then we see 37, 38, and 39 in the last log. Why don't we see that last log? Come on. Because we don't get, could not read line from standard input. No such file or directory. Yes. Error codes. No, and no such directory. Directory. I thought it's end of file. Do we have end of file somewhere? EOF reach the end of the file. Error handle EOF. So looks strange. Looks very strange. Okay, we get an error now. Fine. We should have 2 entries. Yes. But if we do this and then we do 1 signal and then we press, oh, okay, it worked. Now it worked. We have one request and then okay, but the bad thing is that I want to make this thing non-blocking. Get line get line std in non-blocking. You should be able to do this by setting non-blocking mode on standard input, file descriptor 0. Now, if there is no input available, the underlying read system call will return 0. We'll think that this is, and cin will think that this is end of file and set EOF on. When you wish to read from standard input again, just clear the stream's state. The only complicating factor is that this makes it difficult to detect a real end of file condition on cin. Yeah, not much a problem when standard input is an interactive terminal. But if standard input can be a file, this is going to be an issue. In that case, your only realistic option is to forego standard and completely put non-blocking mode on file descriptor 0, poll or select it to determine when there is nothing to read, then read it. Because you will need to explicitly check if there's anything already buffered in streambuff, because that would obviously preempt any kind of poll checking. But by attempting to read something from you will run the risk of reading the buffered data, then attempting to read and from the underlying file descriptor that's now in non-blocking mode, this resulting in a fake end of file condition. To figure out the correct logic you will need to use. Then we make something different. I will do a different approach. Completely. Yes, because this should do the trick. I'm using just the read function. Yes, without a buffer. Manual read. C. Not G. File descriptor. Okay. Blah. Okay, whatever, I will do it. Okay, so just a little application, but okay, we have, I want to have a std string m fragment line this will do the trick, hopefully. Okay, we start with this one and then we say we make a character buffer of size whatever, doesn't matter, 5. num read size t num requested. No, len read. Len requested, len read. Okay. So, and here we say len requested is size of buffer, and then we say len read is equal to read without the stream, without the buffer, directly on the file descriptor. That's way better. We read into the buffer, we say -1. We say len requested. If nothing read, then go out. Otherwise, if an error occurred, fine. If then buffer of num read is equal to 0 in any case. If this is -1 is n. Oh no, this is different. We have to use a fragment then. We have to fill up the fragment. Yes, okay. So we have a len requested buffer, len read. We read something. Read, what can we have? We can have these things. If e again or error number is equal to would block, then break. We don't have these freeze anymore. That's not the line, but this, no. Later on we have the fragment C string. Yes, that's it. We don't have the free anymore. Okay, that's it, I think. Okay, so we read the buffer all the time. If we don't get anything, then return. If this one, then E again, it's okay. Otherwise, we have a real error. Go save log. We terminate the buffer, and then we have a buffer. That's good. That's good. Okay, now we have a buffer, and this buffer, a 0 terminated buffer. And we say char pointer p found. We check the buffer if, no, we check the buffer. P found is equal to man structure const string, and we are looking for in the buffer. We are looking for the new line. If we did not find the new line, then we got some data which needs to be added to the fragment. But if we have found the new line, then we terminate the line at this point and increase the pointer. Now we have terminated, we have split the buffer into two cases, the left one and the right one. We add the left part to the fragment. We add the left part to the fragment. Now we have a full line. And now we consume the line. Now we can consume the line, that is this one. Now we have a new line and we push back the line. And then we say we have consumed the line, we terminate the line, and then we say plus equal to p found. Because we may have some additional data at the end. May be the case, may not be the case, but then we have the rest of the buffer, the second part already in the fragment. We have consumed the old fragment, and that should do the trick, I think. And then at the last state we are capping the buffer. E again. Yes, let's see if this is doing something useful. Was not declared. Num read. Len read. 1, 2, 3. We are pressing C. Build native catching. Okay. What is happening if we... I think I know what is happening. So now we are at the low level. I think it's okay to be on the low level at this point. But if I press Ctrl C, then I think yes. Our application is not allowed to... Okay. I think the main... let's check if we reach this function. If we reach this function, then I understand what's happening. I think we get an application close request. Yeah. So bad. Okay. We have a concatenation of these two programs. We have this application and this application. And they are connected to a pipe. But if I press Ctrl Z, then the interrupt signal is sent to both. Not I always had in mind that the Ctrl C signal is sent to the first application alone, but it's also sent to this application, and this application is designed to be closed just just to be close, because we have a sig int and a sig term. Okay, Linux signals list. Now we say man signal. I think that's better. And what they mean. Sig int, the process was interrupted. This happens when you press Ctrl C on the controlling terminal. Sig term. The process was explicitly killed by somebody wielding the kill command. So if I want to be killed, then... So if I get killed, then someone wants to remove me. But if I interrupt it, Ctrl C on the control terminal, I think we just have to ignore this signal in this special case. And that was the reason, because sometimes I got the error and sometimes I did not. Now I don't get this anymore. That's cool. No, it's not working like that. We have to. If we don't set the signal handler, then we are closed again. So we have to check if sig number is equal to sig interrupt, then we have to just ignore ignoring the output. If we get terminated, then we tell the application that it is not used anymore. But if we got a sig interrupt, then we should ignore the signal. Oh, okay, that's special. Ignoring. Fine. Okay. So what is happening now? Pid of test.sh. Okay, pid of log catching. Kill all log catching. Kill pid of log catching. Fine. Okay, let's do it again. And now I want to have pid of test.sh. What? Okay. TGS testing. Okay, no. I want to stop this application for one moment. So okay, so we have the test script and perfect, and then log catching. Grab multiple entries. I always forget. No, it's a small e. Small e. Always for. Oh. Come on. PS minus if. Grep minus e. Test minus e. Catching. Now I have both applications. Perfect. Now I see both applications. Test is sh and what's kernel loops? Kernel oops. Okay. Log catching. If I press Ctrl C. Haha, then I see that the first application stopped sending something. So this means one application should, the test script should be, yes, shut down. This is shut down, but our application, the log catching application, ignored the interrupting signal. That's fine and that's okay. But we should get an error. We should get an end of file error. Because hopefully this is still working. Let's check. Yes, let's check our process tree of the application. It's still in the main state. And the process tree gets updated if I press enter. Then the connection to the process tree is updated. So everything is fine. The application is still checking the file. Sig kill. Sig term. Sig kill. Illegal option. Use now term. Now it should be yes. Okay, so now we can send a terminate to our application. That's perfect. And now we should have no catching and no testing. That's correct. Okay. But as soon as this thing is stopping, then, and we are ignoring the signal, that's fine. That is working. Both applications running, press Ctrl C. It stopped because the first application stopped. Our application, the log catcher, should still be running and should be detecting the end of the files. Stream. Proc1 inf log len read the is set, yeah, set unsend. Then read, no, not signed, ZS. Do we have ZS? Printf s size t. Yeah, set d, yeah, okay. Seek kill. -1, and sometimes it's because E again. That's cool. Okay, now we say error number. Error number is D, that's an integer. We have always error number 11. Error number 11 is something. E again, a list of, oh, come on, Linux error codes. Okay, I should add this to the literature. Core dump literature, and then we have the log catching literature. Ooh. We want to have a list of signals. What is this? Dash between what? I have what? That sound looks very strange. Okay. Signals list. And then we have the error codes. Error codes. Yes, perfect. List. What is this? Function is like except that if C is not found in S, then it returns a null pointer to the null byte at the end of S rather than O. Oh, that's interesting. Cool. We have to be careful. We have to be careful. Okay. If I press Ctrl C, what is happening? Len read 0. Okay, that has. This is what has. Error number 4. Interrupted system call. Okay. If the application died, then someone the pipe, the output pipe must be open somehow. This pipe, I thought that this pipe gets closed as soon as we press Ctrl C. But the pipe is not closed. How can we detect? Let's do something again. Set this thing to blocking. len read for error number 2. If I press Ctrl C, that's bad. That's strange. How far is information when a non-blocking mode works in order to figure out the correct logic you will need to use? Oh, and if you insist going non-blocking route with and getLine, you will have no easy way to determine if the string returned begins and ends because getLine actually read a new line from standard input or it reached a premature fake end of file condition and not the entire line of input was actually been read. So with non-blocking mode and standard in, you will be pretty much forced to use read instead of getLine. Okay. Okay, we are using read already on the low level. So it's okay, but the only thing I don't get now is if I press Ctrl C and end the first application. Why? Why do we get read 0? Okay. Read std in non-blocking end of file. If non-blocking was what you really wanted in that case, state available as far as I currently think was. What you want is actually for the Git to block until new data is available. This sounds strange. Non-blocking array with pipes in C. Oh no, that's completely different. Okay, then we will switch to the blocking mode. Okay, that's fine. So if then we have a different case. If len read is smaller or equal than 0 and then we just try to read the stuff. 0 and if, yep, could not read line from if 0 and if, okay, this should be fine now. Okay, let's see what's happening. We always get something, and now press Control. We don't have any logs yet. That's correct. Sig user. We should have a log now, yes, at 15. Looks fine. And then if I press Control C. We should have an end. We have an end. So now it's behaving completely like we wanted. So it's not easy to detect a real end of file condition on standard input if it is non-blocking. Sometimes I discover some fundamental behavior of Linux that I didn't know. Okay, so now we can have another case. Now we can have another case. That is, we have in our buffer, we have read 2 lines, two new lines in the buffer, but we are only looking for 1 new line. So we are making 2 sides of the buffer. The first line and the other 2 lines. We don't detect the second new line, so we have to be careful. We have to say while no, if not found, then if we did not find a line, then fine, but what if we found something? While p found, then we have to check multiple lines. And we test this behavior. We test this behavior by increasing the buffer to 50. So we have a big buffer now. And we adapt our test application to say printf index new line. I don't think that this is working like that. Shell check. I don't have shell check installed. apt cache search shell check. apt install shell check. Oi. Come on. Shell check test. Don't use variables in printf form using printf. Yes, I thought so. %s. Are you happy now? Yes. Okay, so we have index, we have 2 lines. We will send 2 lines immediately every time. And then we say A. And the program has to be able to cope with this situation. Oh, come on. Oh, this is happening. All the mosquitoes. Oh, the mosquitoes are biting me. Oh, come on. Okay. If we did not find a new line, then just add the buffer to the fragment. If we found a new line, in the buffer, then the first thing we do is we cut the buffer into two pieces, the left one and the right one. Now, the left part is added to the fragment. We print the line because the fragment has been finished. We push back the fragment. We should now, let's do it like that. Now we have the right part. Now we have, what should we do with the right part? What should we do with the right part? In any case, we have consumed the line and we have to finish the line in any case. Let's make it different. We consume the whole buffer. We say while true. We try to find something. Yes, I think that's it. Somehow, more or less. While true, we have a buffer terminated. There are multiple new lines in the buffer. We go in the endless while. We say try to find a new line. If we did not find any new line, then add the data to the fragment and everything is fine and go out of the while. Now, if we found a new line, then cut the buffer into two sides. The left side is the buffer and we add this to the fragment line, and the fragment line is finished and we print we consume it, we clear it, we check the FIFO buffer, and then we should do what? I think we should make another pointer. P buffer. Yep, and P buffer is buffer. Okay. Every time we get something, then we reinitialize the buffer, and then so this thing should check P buffer. We try to find a new line. If we did not found any new line, then just take the whole buffer and add this to the fragment. Okay, but if we did not find, if we found a new line, then cut the buffer into two pieces, the left side of the buffer and the left side of the buffer goes into the fragment. We add the last piece of the fragment, which is on the left side of the buffer. Then we print this line, we consume the fragment, and then we have to check again, and this means p buffer is now p found. And now again we check we don't yes. Oh, freak me out. That's so bad. That's so bad. I have to be careful. Buff. Yes. Okay. Now we got the left. Now we have increased. We add the, now we this is after this line. We have cut the buffer into two sides, and the found pointer is now pointing to the right side of the buffer. We consume the left side, that's fine, and then we start from the right side and try to find again a new line. If we did not find this, then it's added to the new fragment, which must be terminated, empty. Yes, I think that's it. Oh, very complex. Okay, so zack. Yes. Oh, that's. The important thing is that it should not matter how big the buffer is. Now we should make 5, and it should not make any difference. But even if it's only 5. Then there are cases in which we could have troubles. So, okay, this is it. I think this is it. And yes, it's blocking. It's blocking, and I don't like it, but good enough. Good enough, I would say. Okay. So line. Okay, that's. I think we are finished with this application. Took way longer than I expected. Way longer. So now let's test this a final time. Sig user. I want to check the current content of the log. Makes sense. And I press Ctrl C. It's terminated. Everything is terminated. This both applications got the signal, but this application is ignoring the interruption signal because it doesn't care about an interruption. It only cares if we explicitly want to kill the application. That's fine, because the situation is different. Here we are in the terminal, and from the terminal we send signals to both applications all the time. But in the production case, it's more like the signal that can happen. That means a segfault, for example. It's crashing. This application is crashing. Then the signal source is this application. But in our situation now, the signal source is the terminal itself. So this is a different case. And that was the reason why we had to ignore the signal here. This is a special case. So usually the signal source is here, and this means only this application terminates, and then this application should check, okay, we don't get anything anymore, and then we just save the log and that's it. That's good enough. Okay. Now I want to increase the size. I wait for a moment, I make sig user. I get 6 lines, that's fine. I make sig user again, I make sig user again. That's cool. Now I want to, because, yes. What happens if I get... I always get... That's perfect. Yeah, everything is perfect now. Now I want to have an unequal, an odd number. A. Can I get... Yes, this makes sense, I think. I get the first, I always get a pack of 2 lines, but I have an odd number of lines in the FIFO buffer. This means I always get this 1A at the beginning and 1A at the end. So this is okay. Yes, this is okay. Now I want to do something else. Yo, oh, productions now. I hopefully that the stream is stable and it's working. Took a while, and I learned something again. Yes. Yeah, it's so fucked up. My internet is strange at the moment. I have disconnects some minutes sometimes. How is your bachelor thesis going? I can remember that for me, the bachelor thesis and the master thesis, Vodafone, yeah. Writing the thesis is so, for me it was very hard. It was so hard because I'm so bad at writing text and documentation. I was like, I needed a Red Bull every day to write one single page. It was a war. a fight. No, a fight. It was a fight every day to write the thesis. So I want to kill this catch. I want to kill this script now. For example, we send. Kann ich bestätigen. Yes, this is what I'm so happy that I don't have to do this anymore. You drink Monster. Cool. That's cool. Let's send a signal that is called segfault. We should be able to send a segfault signal to this process. We remove all the logs. Now we don't have any logs. And now it should behave. Now we don't send the signal from the terminal, but hopefully this is working now. This is the last case. If this is working, then everything is like mwah. I don't want to test it. Because now from an external source we inject a signal to this application only. And then both applications should just end and we should have a log, hopefully. Come on. Both applications ended and we have a log. Oh yes, oh yes. Perfect. Yeah, okay, is this cool? Cheers, that's cool. That's perfect. Okay, the first big part. It was very strange to learn that if you read, if you set standard input as non-blocking, what I really want to do in general, but you can't detect an end of file situation in the right way. Okay, whatever. That's. Oi. No. But I think. No. We still have a case. Oh, come on. We still have a case, I think. Because so bad. That's the reason. That was the reason why I wanted to have non-blocking communication. Because now we have. I always want to have a non-blocking communication because now I have another strange behavior. That is, I want to be able to see the end of the log if the first application ends because of whatever reason. Then I want to the first application is crashing, for example, and then I want to detect that I don't get any data, no data anymore. But yes, I have an easy way. I have an easy way to fix it. I show you something. I want to create a log that is called underscore end if the application has ended. Fine. But I also want to have a log if I send a user signal to this application. For example, sick user. If I send a sick user, I want to have the current log. I want to be able to request the content of the FIFO buffer at any time if I want. And in any case, if the sourcing application is has crashed. So if I send this signal, I want to have a log that is called user. That's fine. It looks like it's working, but it's not, because if this command is blocking because the file is still in the blocking mode. So if I don't get any data from the, for example, my source application is not sending me any log inputs, then this code is dead. It's not living anymore, because that's the reason why I want to have everything non-blocking, because now this code should be dead. It's only working as soon as I get the chance to read a file and a line, and then only the request gets processed. So we should be able to test this if I change the test program and say wait 20 seconds. Now I start the program, and for this I want the line indicator again. So we have an end log now, that's fine. But now, as soon as I get the second line, I want to make a user log again. I wait. Now I get the second one. I tried to get a user log, but I don't get a user log because the code is dead. It's waiting for the next input. And in a couple of seconds I should get a user log. Hopefully. Yes. So it took 20 seconds until I got my user log. And that's not what I want, because I can't guarantee that the sourcing application is sending logs. I want the log immediately. Okay, so this is bad. But fortunately, so we have the situation that we have to use standard input blocking. But we also want to have this one. The cool, usually I would, now I would send all this code in the new process, in the new thread. And that's something I don't want to do, but okay. Okay. But we have the cool situation that we are registering a signal handler, and then we just move this code into that section, because then it's guaranteed to be executed. We only have to deal with the fact now that we have to save the, yeah, okay. But then I think the last the last piece is done. Okay, bool. Okay, warning log, perfect. Okay, this is, yes, So we have a request handler, and now this we can't execute this function. This function is a static function, like here, because it's registered as a signal handler, and we can't execute a member function in a static. Oh, this mosquito is fucking me up. Okay, I make it simple because I don't care anymore. I say log static log catching pointer p log log catching pointer log catching p log is equal to null. I don't care. And I say, is this if not p log return and then we should be able to execute the member function from the pointer. That's it's not beautiful, but it's good enough. Yes, I think I'm satisfied. So now we should have a different scenario. Okay, it's compiling, fine. We should now get the log immediately. And if that's the case, then we are happy. Then I will test all the cases. Oh, sig user and user log immediately here. That's it. That was the final piece. I press Ctrl C. Then I get the end log. Yes, perfect. I make ps-f grep test. I kill seg fault. The test apply. That is the parent. No, this is the Oh, what did I kill now? I think I have killed the wrong application. Okay. Again, very interesting. We got a log, that's fine, but as you can see, that's strange. If I have to yes, I start both applications, then I say pid of test sh. It's not pid of bash. ps grep test test.sh. No, not cool. We say we make a script. Come on, we make a script that is called sig user to log catching signal. Yes, perfect. And then we say sig source, whatever. And then we say this is still working. Test script not running, and we want to make a segfault to the sourcing script, and we say exit 1 echo. Okay, s minus ef grep e test .sh e bash sig source grep bash. Perfect. Then we say pr minus squash minus squash, and then we say cut minus d f2. So that's the process pointer, the PID process ID, and then we say sig source. We kill the source and we wait until the next entry, and then we say sig source. The strange thing is now it's still running because we are in the sleep state. So we have a test script. We have a test script that is doing something, and then it's sleeping for 20 seconds. It's sleeping for 20 seconds, and then if we send a signal during this time, then it seems that it's ignoring it. So sleep. Let's do something else. Can we terminate? Let's do it the hard way. Wer nicht hören will, muss fühlen. Yes. But okay, let's think about it. What is happening here? Because actually I'm not killing the test script, but the application bash, which is interpreting the test script. It's interpreting the test script, and it's executing all the lines of code in the script. It has executed sleep, and then it's sleeping for some time. Okay, Linux kill sleeping process. Kill a sleep process. All sleep processes that are running. No. How to kill in Linux using kill, all, and pkill. Linux can't kill a sleeping process. A process is in S or D state is usually in a blocking system call such as reading or writing to a file or the network waiting for a called program to finish or while waiting on semaphores and other synchronization primitives. It will go into the sleep state while waiting. You can't wake it up. It will only proceed when the data resources in it waiting to become available. This is all normal and expected and only a problem when trying to kill it. You can try and use strace to find out which system call is currently happening for process PID. A process blocked in a system call is in uninterruptible sleep, which, as its name says, it's really uninterruptible even by root. Normally, processes cannot block seek kill, but kernel code can, and processes execute kernel code when they call system calls during the seek kill will only take effect whenever. Now I have learned two things. So strange. Provided you have the pin and the kill the button and again to work immediately. However, kill -9 is not guaranteed to work immediately. All signals, including are delivered asynchronously. The kernel may take its time to deliver them. Just the time it takes for a target to get however, if the target has blocked the signal will include until the target unblocks it. But kernel code can file on network. So there are cases. Can I wake up? Maybe I'm able to Linux wake up sleeping process. Is this possible? Continue. If you mean state T stopped. No, we don't have the state T stopped. Okay, that's just interesting. We don't have the case. It's just interesting. Okay, and it's fine for us. What's pkill sleep? Yeah, pkill sleep is, what does pkill do? Pkill in general, this is not kill all, and pkill for sleep is not safe, I think, because there are other processes which may use this. Looks through the currently running processes and lists the process process IDs, which makes the selection criteria to stand it out. Only called as is and owned by root. Called will only list the processes called SSHD. Yes, that's what okay, we can do it. I think it's, let's check it first. If there is something sleep, grep, sleep. Now I can do it safely. Okay, so I start the thing and then now I have to change the script again. Okay. We remove all the logs and now I start the script. It's sleeping and I try to p kill sleep. Terminated. Oh, interesting. And that's different. Now what has been terminated? Something has been terminated. What? Yes, because... No. I don't understand this. What is going on now? I don't understand what pkill is doing. That's very interesting. That is what you should definitely do, executing commands you don't understand. So I'm doing bad things right now. Just executing and see what's doing. Okay. What looks through the currently running processes and lists the process IDs which matches the selection. All the criteria have to match, for example. But it's not a pgrep. Name another. Okay, we should just first use pgrep to check what this actually means. So we have ps minus ef grep test, and then we say pgrep sleep. You see that... Whoa. Oh, okay. No, it's changing, but yes. ps minus ef grep sleep. Sleep 20. And pgrep is giving... Yes, it's just killing the sleep itself. Yes. One moment. Let me think. Yes, that's it. You see, this is the bash. This is the bash. We just have to kill both, and that's fine. We just have to kill both of them, and that's cool because pgrep gives us... let me think. Pgrep sleep gives us... what? No, we just have to... No. pgrep is not what we want, but sig source, yes, we want to kill this one, the bash script, and then we want to kill... What do we want to kill first? We want to kill the parent with this. Perfect, and then we say that's working. What if we have multiple... Yes, yeah, perfect. We say echo p. So I want to find the test script. I don't want to kill it at first. So I just want to run it. Yes, fine. Okay. We don't kill our script first. We just want to check. We say ps minus ef grep test. test. That's the first thing we do. We just output the files and yes, let's make E and then E sleep. Okay, then we see both things. Sig source. As you can see now, we have these are the processes that are running. We have a bash script that is reading the script, a bash application, and shell script interpreter application that is executing this shell script, and this thing has executed the application sleep, and now we want to find this PID, and we have found this PID. That's fine. And now we want to find this process ID, and we want to kill at first this one and then secondly this one. So we just have to yes, and then I would not use pgrep, but I would use this one. Grep this one and then squash again, and then we should get let's see what we get here. We get 3. Yes, that's that makes sense. Okay. And we say grep sleep. So now we should get 2 PIDs. The first one is the parent and the second one is the sleep thing, and now we can kill the second one. The first one is this, and the second one is sleep not running, and otherwise we kill, just make a normal kill to the new process ID, and now it should be working. Sig source. As soon as we get a new one, let's see. Okay, we don't have. We kill. Okay, this did not work. Why? Isn't this reliable? We have this. Yes. And the second one. Maybe we should. Maybe we should just kill. P1. Oh, come on. P1. P2. P1. P2. Make a kill seg fault here, and then make a kill the sleep with this one. And sleep not running. Okay, and the bash script is this one. And the other one is this one. We have to kill these two processes. So and now, yes, that makes sense, hopefully. So, come on. So, yeah, perfect. And we killed both. Yes, perfect. Holy moly. That, and now we should have a log immediately. So last test. Such a simple application, but it's horrible. Okay. We don't have a log, and we want to have an end log immediately as soon as we kill this test script. It's killed, and we have a test log immediately. That was a journey. That was a journey. Let's go. I think now I get another beer because now everything is working really as expected. I think I say sick user. I want to have a user log immediately. Fine. What is kill? What if I kill the logging application? Then the logging application should just end. So one moment, I get the beer. That's very important. Ui, that's a strong beer. I don't know if I should drink this, but actually this was kind of a hard task. And I'm on vacation, so it's okay, I think. If I'm too drunk, then I have to end the stream. Prost, Egeshegedre. Prost. So, yeah. Perfect. I did not find any Linux application that is doing this exact thing I want. So that's I'm very satisfied. Yeah, good night, Productions. Thanks for the support, and hope to see you next time. Next week I'm on vacation, so I'm not streaming. But have a good night. Bye. Thanks. Yeah, cool. Very cool. Okay, so I have to save this thing now. Log catching. Thanks, Productions. Now, TGS deployment. Oh, this thing has 4 megabytes. Oh, okay. We have to. That's not correct, I think. Yes, I have to remove this dependency. That's too bad. Log catching file system, that's okay. And now I compile this thing. And app version has not been found. I can remove all the dependencies here, I think. Threads, JSON. I think that's the problem. lib time. I don't want to have res and lib time. Main CPP, what is JSON? Ooh, yes, this thing is, ooh. Okay, we do something else. We do something else. Yes. Yes, we remove a lot of stuff. Okay. 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 But it's okay. It's okay. Because we say number of lines is a new public variable. And we have mname base, which is a std string mname base. And we say yes, perfect. P application is of type LC supervising. No supervisor, come on. No, stop. We have to do something else. We have to make a static variable, two static variables, because it's easier. And then it's not called mnum lines, but this one. And we say yes, mnum lines is equal to 0 and name base is equal to, yep, okay. And then mnum lines is set in the main by saying log catching num lines is equal to that. We don't need the verbosity, the debug environment completely. And log catching name base is argument name base get value. And then we remove the arguments completely. Haha. Okay. No. Yes. So we have this in the public area, and we have to include this in header file, and then we can remove the environment completely, and then we don't have JSON anymore, hopefully. We can remove app version. The version is command x66 unknown. Yes, yeah, okay, we are, so we don't have this. Num lines. Yeah, fine. And here we have not the environment anymore, because we don't have any environment. But we have name base. Name base. Fragment lines. Perfect. So let's make sig user. We saved a lot of space. That's cool. So let's again make a sig user. Cool. Let's stop the application. Everything is working as expected. And we have removed a lot of dependencies which are very bad. So we only have tclap dependency. And the name is correct. That's still fine. And we still have sig source. If this is not running, then it's good enough, I think. Okay. 1 megabyte instead of 4, that's cool. Okay, I think we are finished with the application. Big journey. Okay, we have default values 100 and app. Okay. Test 1. Fine. Stop. I want to, last thing we want to do is remove the output. Okay. Sig user again. And so now I have to save the stuff, because now we have everything we need. Okay, boah. Just a little application, but very important. Okay, process common. What has changed? Unix standard, yes, okay. File system is yes, it's already Unix stuff. Okay. File sys add header. Uni standard H. Yes, okay, that's good enough. Come on. Ah, come on. Copy. Git remote remove origin. Git remote add origin. This one. And then we say common.git remote min v git push yes, fine. Okay, that's good. Update processing common. Yes, that's it. Let's see. We have, we can remove some stuff. We can remove the environment and the resources hopefully, and then in resources cpp, hopefully this is working as well. That's the last cleanup. Mason setup build native. Okay, perfect. Now we have removed the last files. We have scripts. This is not depending on anything. No directories. This is not depending on a directory. This is not depending, and this is not depending. Okay. Perfect. We have a Mason file, a main file, a supervising file, the application itself. We have some test scripts, and that's it. Cool. Add application. Nice. Okay, if you want to check out this application, then you can do so by going to github.com, no orientation programming. And here we have this in the examples. Check it out if you want. This is the result of today's stream. Cheers. Wow. Wow, this beer is hardcore. Okay. Read, get line. Yes, very strange. Okay, notes, log catching, notes, end of file detection on std_in, not easy if std_in in non-blocking mode. And then another note is sending sig int from terminal affects all applications along the pipe. Then we had something else. We had something else. Yes. Kill does not work. Kill is not executed immediate in some cases. Okay, that's good enough. I stream, yes, string time. Okay, that's good. So we have the log catching. The log catching is done. Your last log lines. We should. Can we do this? And oh yes, that's working. Oh yes. Cool, I did not know that. Perfect, and last log lines is done. Oh, now we have to do the rest. You can check out the application if you want for a moment. I need some time. A short break. I'm back in a minute. Okay. So that's the first thing. we did. So now the next thing would be the core dump itself. Address version, yes, process tree is, I think it's in this order. Linux enable core dump. Okay, we have and preparation content report. Yes. Content report preparation. Log catching, and this is core dump. Now the structure is better because we have a preparation service file. We did not make the service file yet. But the content report, we have last log lines. Last log lines, application log catching, save only n lines in memory, save log content to file as soon as user requested log. Sig user 1. File name, source application stopped, finished, terminated. Okay, application log catching, save only n lines in memory, save log content to file as soon as standard enclosed, source application terminated. Oh, that's better. Okay, notes, literature for this task. It's done. Okay, core dump. Now we have the core dump. Oh. I think good checklist why core not generated. The core would have been larger than the current limit. I don't think so. Okay, log catching. We can remove all these lines now. Oh, cool. If we have a segfault, now we can switch completely. Log catching is done completely. And we can, yes, copy this file. Okay. Okay. Switch. We have to take a switch. We are not testing the server now, but we are just we only want the core, and the core is generated with these. Yeah. Okay. The switch is hot. Okay. That's a good checklist. You don't have the necessary permissions to dump core directly and file. Notice that core dumps are placed in the dumping process current directory, which could be different from the parent process. Free space. If a subdirectory named core exists in the If a subdirectory named core exists in the working directory, no core will be dumped. If a file named core already exists but has multiple hard links, has the bit enabled column will. Okay, the same will be the case if you have no read permissions on the file. Has not changed working directory. Dumpable flag. Some kernel versions cannot dump processes with shared address space, aka threads, but will append the PID to the file name. The executable could be in a non-standard format. Not supporting such dumps. Each executable format must implement a core dump routine. What? Core dump routine. Okay. The segmentation fault could actually be a kernel oops. Check the kernel system logs for any oops messages. The application called exit instead of using the core dump handler. Make sure your current directory at the time of crash may change directories is writable. Also check core pattern that may redirect core dumps to another directory, and that directory must be writable. I think I know what's going on. Whoa. But if this is the reason, then this is quite intelligent. If this is working like I think it is, then this core pattern is quite interesting. Let's make a directory called core dumps. Core dumped. That's beautiful. I think that's beautiful. Because I don't get any dumps, because now if I enable core dumps in general, any application that is crashing would create the core dump. But now it's not creating a core dump unless I make a directory where it can store the core dumps. Okay, that's quite cool. That's quite cool. Yeah, that's okay. Nice. Okay, now I want to check core. Yes, I want to check this stuff because the output seems a little bit strange. T in seconds, that's I understand. I used this pattern, core dumps. Perfect. This is E is bad because I changed the com name. Let's check TGS. Why do I have... Oh, okay, one moment. One moment, okay. I clear the dump. I clear the dump and I say Mason build. And I want to see the show address ID. Now I have to recompile the whole server, I think, yes. Fine. Now I can check. Oh, yes, game supervising. This is the root process of the entire application, game supervising, and I think the common name for the common name is this. Yes, proc this and then com. Oh yeah. Com. We have this sequence 95 E0. Okay. This mosquito. Okay. I think it has something to do with the addresses. Which one? Is this the root process? I think. Adding process tree here. Oh, yes. Oh, okay. It's the ID of the last peer. Oh, okay. Then we have to change the processing core. Grep. Okay, it's because of this P control. PR control. Set name buffer. It's because of this. Ooh, and is okay. Proc state. Okay, this is not what we want. So we have to make an if. Oh. What is this function doing? This function is changing the name of the current thread. Now we have a root process. In this case, it's game supervising. In any case, oh, that's it. That's it. Oh, hopefully, yes. Come on, yes. I think that's it. Let me think. Only if, yes. Oh, okay, this is it. Green. If and not driver level. If driver driven by new internal driver, If not driver level. The driver level is incremented as soon as we have a new internal driver. It's not perfect. No, it's fine. I think if we can theoretically create new process in general. If we create a new process, then it's driven by the parent. We can create a new process in a new driver. That is a new thread. But we can also start a process in driven by an external driver. This means we are not allowed if our driver level is 0, then we are not allowed to if we don't have a driver level, we are not allowed to set the thread name. Why? Because in the usual case, the main application, the main thread does not get renamed. Only the worker threads have a specific ID. Only the worker threads. Maybe this is better. Maybe that's better. A better selection. Only if I'm driven by a new driver. And only a new internal driver. Because that's a new thread. Only if I'm driven by a new internal driver, then I can rename the thread. And only in this case. Not by an external driver. Yeah. Yes, that makes sense. Okay, interesting. Now, let's see what we have here. Oh, no, stop. TGS, then. Now the application is still called TGS, and that's what we want. Now I can check the core dumps. I can reconnect and produce a illegal instruction core dumped. And now the core is called TGS like I want it. Yes, that's cool. And the other dumps, or the other dumps are called maybe how I renamed the threads, then this would be perfect. Ooh, fine. Only if I have a new internal driver. Then I can rename the thread only for worker threads. Only for worker threads. Uh-huh. Uh-huh. That's cool. Oop. Okay. Core grind. Yes. Uh-huh. Okay. Okay, git check out TGS Mason build. Now I recompile the whole thing, or come on. Stream is still working, cool. Core dump, let's try again a core dump. Illegal instruction, we have this. Okay, now the only thing that is strange now is this. What did I do here? %s number of signal causing dump. Number of signal causing dump. Holy moly, what's going on? What is going on? Hey, TCAP. How are you? Thanks for the raid. What are you doing, guys? I'm talking in English. If you're a German group, then feel free to write in German. What did you do? Hi. I have never seen your stream. What is your stream about? Which area are you working on? Nevertheless, I will give you a shout out to the people. TK1, check out this guy, C++ game dev. Then the shout out is very good. C++ game dev usually, but lately I've been playing around with making a language. Cool. Greetings, friends of deep thoughts and sometimes something completely different. Friends of deep thoughts and sometimes something completely different. We are making a game server here. I don't know if it's written in C++, and if you are motivated, you can connect to the server. Yes, the game server. One moment. Serve X. We are playing around. We killed the application for a test. TGS start. Now we should be able to connect. Yes. So if you have installed the application Telnet, it's installed per default on Linux, and you can activate it on Windows. And in this case, it's not dangerous to connect because this application is not telling you to input a password, so no sensitive information is collected. If you connect with Telnet to the gaming server, then you're a guest and we can play Connect 4 together. For example, if you connect to the server again, Telnet Nigelos, then you see the server and you can join the server by pressing enter. Oh, somebody connected. Cool, then we can play a game. I'm pressing 2 for team 2, and if you press 1, then we can play. Oh, perfect. Then I should be able to press enter. Yes, the game is starting. Left and right. Left and right. Oh, you already. Oh, cool. Cool. It's working. It's a lot of fun. That's what we made in the last. Yeah, I think I like it. It's cool. But usually I'm losing because I'm not a good player. I can only code it, but I'm not a good player. Oh, that looks bad already. That looks bad already. Yes. I think the best thing I can do is this one. But I'm not sure. Oh, come on. What should I do? Oh, that was a good move. That was a good move. Ah, damn it. This was too easy. Oh, I have to be careful. Oh, no. Oh, yo. Oh, yes. Oh, yes. Mwah. I have to make a screenshot. That's cool. So, and then we are in the lobby again, and then we could make another match, and so it's immer switching between match and lobbying, and of course spectators can join at any time and watch the game. So it's working quite cool already. And yes, so this is what we do. That's what we're working on. And at the moment I'm working at the debugging tools. Yeah, it's quite fun. It's quite funny because the project has quite a lot lines of code already. I think we have about 25,000 code lines already, because a lot of stuff is working already. We have implemented an SSH server, so you can connect with SSH as well, but that's only for registered users and supporters. So as a guest you can always play, and with SSH you can create an account, and then all the password stuff is encrypted. And yes, what we are doing now is we prepare the debugging tools, because if the server is running on the host, on the remote host, then and it is crashing, then I want to have some stuff. And today we implemented a cool tool that is saving the last log lines, because I don't want to use stuff like tail or something, because it's a little bit different. I want to start the server and I want to have the last log lines. If it's crashing, then the last log entries should be saved on the host, so I can check out the log. And this should be done in a specific way. But that we have finished that, and you can check this out at github.com no-orientation programming. So you said you're working on the C++ game. Which game do you have? Do you have something to show us? A link or something? Or a picture? You can post a link here, or in Discord you can post a picture. But if you have a link, then you can open it. So the entire all the applications we are creating have I got disconnected because I was inactive, but you can create a server by yourself. All the stuff he has a lot recently. Epic online thing. Epic online thing. To join if server is open. So that's in Windows application. I don't know if I can run this thing. Because I have Linux, but maybe with Wine. It should also compile on Linux. Okay, cool. Linux build. Cool. So I just should be able to execute Linux build. Okay. Is this what I want? I'm not sure. Clang. Just Clang? Yes. Apt install Clang. If you have that installed, yes. Oh, boah, for 600. Yes. How can I build this thing with G++? Ah. Sometimes my CC, if CC is, let's try it out. No, yes, yes, I have to install I know what I have to do. I have to install all the graphic stuff, and it's okay because I am also coding OpenGL stuff sometimes. So I just have to know which one I need to install. Okay. Search. Cannot find LGL init. Do you know the commands I need for these two libraries? libgl, just libgl or something? apt-get search libgl. Which one do I need? libgl dev, I think. apt install, I think that's it. That's one of them. I think. Yes, let's. Oh, yeah. At least one step further. Ignoring Bragner error. Ignoring Bragner warning. In function. L value required. Level of assignment. Init. Let's install init for one moment. apt cache search lib net apt apt install lib. We just need lib net dev. That are the library stuff. I have never heard about libinet. What's doing it? All warnings being treated as errors. Okay, fine. Why? V error, because we have V error. Now the warning, this warning is not an error. Bragner warning, ignoring, that's okay, I think. Cannot convert. That's to what? To M to 128. Do you know? I have time. I've completed my tool, the last loglines tool and the dump. So I'm in a that's a good time to debug some other stuff. So if you know what is happening, I could check source. Wow, exciting to see the Linux side of this. Yes, sure. Let's try to get this running. Okay, we have source, external, and then we have I think I have installed all the things I need, so I can remove this. Warnings, yes, this is cool. I am using this as well because for me a warning is an error. But okay, for one moment I will wait a moment. So yes. Okay, I think this is looking, but haven't made a payment for it. Okay, can you tell me what I should do? In STP in image. online what the hell, 3000 small file. 3546 at this. This is some how is it called, intrinsics or something. So these are the I think the intrinsic functions of the processor, or is it? In source client inline you can add undef 0. Oh, sounds easy. Undef 0, okay. In source client CPP undef inline 39. Here. Oh, I had this somewhere too. Undef 0, and then define 0 is this. Is this? No problem, no problem. Okay, let's see if this is doing something. Define 0 after the include. Inline, okay. After the include, like this. Undef 0, then the include, and then define 0. Yep, okay. Mwah. Way better. Multiple definition of first defined here. In function, multiple definition. Big math. But the code seems to be clean, not that many errors for if you have implemented this stuff in Linux, in Windows. In Epic Math, just add func before the function header. In Epic Math. This thing is in source Epic Math, line 248, and then func. Func is just defined for static. I think I fixed it, but I didn't commit maybe. But okay. Oh, that okay. So looks fine. I can give you the diff if you want somehow. So this is the diff. Git diff linux.patch diff. So this is the that's the VI problem I have. So I used G++ and then the V error and undef 0, and that's all we did. Okay, so now I've compiled something. Oh, client CPP. Okay, so now I have a client. Is there a help? Okay, enter character name. Character name needs to be at least 3 characters. Oh, wow, cool. that looks cool. Okay. Yes, at least 3 characters. Nicholas. What the hell? Nice. What? That's cool. So what I'm supposed to do? Okay, I should not touch these. Oh fuck. Ah, okay, then I'm transparent. I have only one thing to live. Level 2. That's a cool game. What? Oh, what the hell? I'm in level 3. Oh, that's cool. We are connected as well, but you don't see us. I think it's a Linux problem only. Oh, I see you. I see somebody. Cool. So it's somehow multiplayer. Oh, what the hell? How should I avoid this? What? What is everything lethal? Blue don't kill. Blue don't kill in air. That that's a that's a cool that's a cool mechanic. Okay, I have double jump. Yes, I've seen this at them. Whoa. And F to dash. Okay. I try to dash. Okay. It seems to be a bug that only happens on Linux, that you don't see players that joined before you. Okay, so Oh, but now that's so cool. Nice. But sometimes I see the people with their names. Now I don't see my own name. TCAP is here, and okay. Whoa. This level is hardcore. How? You revive when all others die. Oh. 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 And they are very hard to see while you're alive. Okay. While I'm alive, they are hard to see. Okay. That's cool. That's cool. Okay, that's a little bit easier, I think. For me. That's a little bit easier. Oh. Okay. The fourth level was really. Purple don't hit on ground. Okay. Whoa. That's a cool game. Oh, nice. Nice. I have played Horencha. I don't know if you know this game, but that's one of the best games, one of the best vertical shooters ever made, I think. It hit me. Okay, I'm dead already. Oh. No, damn it. Cool. So, am I dead? Whoa. Okay, whoa, that's hardcore. TCAP. Wow. Look at that. What? This is hardcore. Oh, come on. I think now I understand. Score top left more, time life more. Okay, come on now. Double jump. Almost. Come on. That's cool game. That's nice. Oh. I like games like that. That's really cool. So how do we get into the next level? What's the criteria? Whoa, come on. Whoa. Oh, survive 15 seconds. Okay. Whoa. Holy moly. That's hardcore. Ah, okay. The 15th. Ah, that's the counter. Okay. So I will get us into the new level. Yeah. Come on. Stop. Oh. Oh, yes. What? Huh. Oh. Come on, do it. That's cool. That's the concept is very cool. Oh. Respect. Really good work with this game. Oh. It compiled almost immediately on Linux. Nice. Oh. You can chat. How nice. Oh, what is happening? I can't move anymore. I can't move. Why? Ah, okay, I have pressed N. Ah, okay, Enter is test. Ah, now I can chat. Ah, I understand. It's typing, yeah? It was typing. Buh. Ooh. Visual. This reminds me of Horencha. Oh, that's cool. That's very cool. So the blue ones do not kill me if I am in the air, right? Oh. Okay. It's too hard for me to follow at the moment. They do in this level. Okay, they do. Oh, I'm stuck in the corner. Wow, that's a hardcore level. Level 19. How many levels are there? Oh. So if if one person survives in after this 15 seconds, then it's the next level. Oh. That's cool. Man, that's amazing. Big respect. Oh. Cool level. Fast from the left and slow from the right. That's a very cool level. Because Uy, 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 uy. That's a cool game. I tried to duck. Oh, come on. I tried to duck, make a duck jump or something. Come on. Boah. Boah. And it reminds me on the down for S, down or S. Down. I can't press down. What is happening if I press down? S and down is not doing anything. Oh. Ah. Ooh, okay. Oh, that's okay. Oh yes, that's useful. Ah. Mm-hmm. No way. Infinite jumps. Oh, cool. That's very original. That's cool. Oh, you are kidding me. On the ground. My brain is at 100%. So actually it's as a group we can survive more easily. Oh, come on off. That level is hardcore. Okay. Come on. Oh, come on. Oh. No. Oh, this is a different level. Mm-hmm. Oh, come on. Fucking mosquito. Level 25. Nice. Oh, you made it. Oh, that's hardcore. Come on. Oh, yes. What? That was cool. Almost. Come on. No, thanks. Yes, I played a lot of games like this. No. But sometimes I have no chance. And I don't have enough beer for that. Oh. Oh, you did it. Cool. Yep. Come on. Oh, no, almost. Infinite jumps. Infinite jumps. That's easy. Oh. Come on, infinite jumps. I can fly now. Cool. You're nice. Come on, you're nice. What is now? Oh, from the bottom. Oh, come on. Come on. What? I did it. Nice. Oh, what? What? Should I do now? Oh, no, no, no. Oh. Boy, you managed it to get through that hole. Nice. Boy, that's hardcore. Oh, T-cap. This was a nice move. Oh. That's actually quite hard. T-cap, how can you jump through this little hole? Oh. Oh. Almost. Now what? Whoa. That's hard. That's really hard. But all the levels are unique. Very cool. Oh! Almost. Nice, 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 nice. Oh. Yes, what do you do here? Wow. T-cap, that's your level, huh? Wow. That was hardcore T-cap. That's definitely your level. Come on, do it. Please, please do it. Come on. Wow. Oh yes, thank you. Thank you. Hey, what the hell? Oh. Ah, okay. Oh, yes, I can understand. I understand. Yes, I've probably too. Boah. Oh no! Ah! I will give you a few attempts, then I will beat it. Uh-huh. Oh, okay, now I'm already completely empty. But it's a very cool game. How many levels are there? Yeah, we are at level 30 already. 3. I managed 3. Come on. Yeah. Aha, okay. Wow, that's easy. That looks easy at least. Okay. And if I press escape, how can I escape from this thing? I don't know if I messed up the input handling on Linux somehow. No, at least the arrow keys are working perfectly. Alt F4 close. It's really hard to get the right height for the jump on that level. Yes. Okay, yes, I see how this should be working. Dashing is F, I think. Oh, you managed it. Oh, what? Yes, oh, look at that. Come on. Oh, yes. Oh. That's more. That's more the kind I like. It's cool that every level has a unique style. There are so many levels. Oh. Yeah, cool game. Cool idea. I really like it. It's nice. Oh, nice. Oh, what the? No. You. Okay, this is not hitting me as long as I'm floating. Yeah, okay, I get it. Ooh. Yeah, okay. That's. You should not be distracted by the center. Okay. The movement is very cool, very smooth. No way, it's, oh come on, it's inverted. Oh no, that's hardcore. Oh yes, oh no, fuck, that's impossible for me. My brain is not ready for this. It's not ready, it's no chance. No chance for me. Come on, how can you? There are so many different styles. That's cool. This you need luck in this one, don't you? Because yeah, I must say that it's it costs a lot of energy and concentration. Come. I'm getting weaker. I feel it. That's a cool game. Is the server up all the time? And I have to follow you. That's cool. Thanks for the follow, guy. TCAP. You should. Yes, the server is in Windows application, I guess. Anyone can host it. We have a server. We have a Linux host if you want to run it there. The host itself should be up all the time. come on. No, I'm finished. It's I see that I'm not thinking straight anymore. This is the last. Okay, then let's do the last one. I really want to finish this. Come on, let's do it together. I try my best, but this is... It's doable. It's doable. Come on. Okay. Oh, you're using the small... the fast... Oh, okay. Oh no. That's even harder. There, that's even harder. Come on, let's do this, guys. Oh. Oh, from the top. I got finished from the top. Come on. Wow, that's hardcore. That's hardcore. Is there any pattern I can use? From the top. From the top, yeah. Oh, yeah. Oh. Mm-hmm. Oh. Oh. Unfortunately, I'm not capable. I don't have the skill anymore to escape. Wow. It's really energy consuming. Come on, let's do this. I want to see the end. No. From everywhere. And it's very strange that the red dots are coming from the... There is no ending, sadly, kinda disappointing. Oh, come on, T-gap. It's similar. It's like whoa. It's no chance that I survive 15 seconds in this level. Come on. Oh, damn it. I finished so many hard games like Bennett Foddy, getting over it and stuff. But this, well, that's. Oh. Yeah. Okay, I have to use the fast down movement more often. Oh, yeah. Oh, I think I got it. Fuck, almost. I think I have the pattern. No, I don't. Come on. But it's getting better. You have to use the down movement. The yellow ones are bad. Oh. The yellow ones are so bad. The green and red ones are okay, but the yellow ones are killing me. It's so hard to see if you go in the wrong direction that it will be over soon. Maybe we should. Do you think we can finish it today? I don't think so. I'm completely brain dead right now. I don't see anything anymore. Come on. Come on, TCAP, do it. Oh, yes, come on. No. What's that? Oh, you did it. TCAP, nice work. Really nice work. Amazing. Very cool. Yeah, nice. So if in hopefully you see the fetch. So only a few changes and then it's working. So, amazing. Respect. Big respect. Cool. Thank you guys. That was an experience. That was very cool. So I have to follow it. I have to check this out. This is very cool. And it's so cool that it's working for Linux and Windows. Nice. How many lines do you have here? What? Only 5,000 lines and such a cool game. Are you kidding me? No. Really? Tmux, thanks to us as I usually make things Windows only. Yeah, but hardcore that this is working for Linux and Windows. Tmux, no, I'm not using Tmux. I'm using the VI file manager and the Terminator terminal. Only these two. My main game is a tower defense. It's around 60k lines. Wow. But it's impressive that only 5k make such a cool game. And it's multiplayer. Yeah, nice. Respect. Big respect. Really. Pwah. Nice game. For everyone who is has joined in the last time, go to TCAP, check this out. This game is public on GitHub. Do you have a link? I use Inet library for online. It makes sending packets pretty easy and it works on Linux too. Okay, Inet. Shared client, platform client, Linux platform client. And GL, okay. Still afraid of merging. Had it to run on Visual Studio. Still afraid of merging. Merging what? Had it run on Visual Studio. What are you merging? Funk, okay, static, load GL funk because of micro. Very cool, very cool. The only thing I managed to create so far was some buttons in GL. that was made in OpenGL, but yeah, it's takes a lot of time. Cool, very cool. No, nice. I'm very happy that you managed to get this compiled on Linux. This game does all the OpenGL stuff without libraries. Maybe it can help you. I will definitely look what you're doing here. That looks very interesting. DL Open Client SO. Okay, that's the Linux platform client. Okay, and then you have the shared libraries, client library. Yeah, cool. I will definitely take a look at it. Epic online thing. Yeah, the name is cool. The name is very cool. Build client DLL. Oh, okay. Yeah, the game can be compiled and it uses the changes without having to close it. What? The game can be compiled and it uses the changes without having to close it. Oh. Okay. Oh, okay. That sounds interesting. The client DLL. And server DLL. A server. Okay. If I make the Linux build, then the server and client is built. Oh. Restarted. Okay, cool. And then come nice. It's all very handmade. Yeah, but it's really cool. It's amazing. Big dog. Okay. Okay. I don't have sound on. There is a sound on Windows. Okay. It's cool to play without the sound on Linux as well. Basically, the whole game is in a DLL. So when you recompile, the part platform layer reloads the DLL, so you get the code changes without having to restart. Yeah. Okay. While running. That's a strange concept. It's not done on Linux, though, I think. Okay. So, so you need the platform. Platform client. Yes, reloading the code only works on Windows. Linux does have shader reloading, though, I think. So you can edit shaders live. That's cool. So you're reloading the shaders every time. And that's cool, then you can play around. Create window. While running. Only when they change. That's smart. Need to reload the LL. Okay, that's in the header file. Oh, my VI. Sometimes I can't open a file. Oh, okay, no, this is fine. Need to reload DLL. Find first file A, compare file time, last write time, result, then if you need to reload, then load this copy file from build to client, okay, and then load DLL, update game, get proc address. That's cool. I was a Windows user. I'm 50%, I was 50% Windows user, and now I'm Linux user. With CTEX installed, you can run Linux build text to generate tags. What are tags? Very cool. Nice. Yeah, reloaded the LL, okay. Update game. There are files that show the location of functions in the code. To jump to function. Okay. There are files that show the locations of functions in the code. Interesting. Yeah, I'm so used to use egg, but nice. There are only 5,000 lines of code. That's impressive. That's very impressive. Cool. Yeah, thanks for this great time. It's cool to see that project. And your other project has 60k lines. Tower defense. I assume that's counting the external libraries. No, I don't know. It's my script is only counting CPP files. We are probably closer to 2 to 3k. Yes, then it's called the external libraries. Cool, the fragment shader and the vertex shader. Nice. Cool. Oh, that's the vertex is quite sophisticated. Yeah, the effects itself themselves are very cool. It's not, it doesn't look cheap. It's quite cool effects. Windows Borg, L result, yes. I know these words, high word and low word and L result from the Windows time. Handle from window or something. V param, L param, yeah. That's an API call, yeah, LP function window broke, yeah. Cool. I have a nostalgic flash now. That's cool. Respect that this is working on Linux perfectly. Nice. Very cool. I'm not... this thing, this terminal game server is not working as good as your game for Windows. Yes, Windows defines a bunch of common things to their own thing, kind of annoying. Yeah, yeah, it's annoying. Sometimes it's annoying because depending on what you're doing, sometimes the systems differ a lot, and some code is just nasty because of that. For example, I have in the processing core, if I make a TCP server like default define bool int okay, yes, that's strange. Also the network stuff is kind of everywhere. You have these defines. The networking stuff sometimes is quite... the low-level networking stuff is very nasty sometimes. You need a lot of defines. For example, I have a socket, and on Windows it's called close socket, and on Linux it's called close. So and stuff like that. And if I have an error, then I need to use VSA get last error or error number in Linux. that is bad. Look at that. There are two functions doing the same, but the parameters have the different order. They just carry it around to keep legacy rolling. Even in Windows 11, it's a love-hate relation. Yeah, absolutely. Absolutely, yeah. Setting a file non-blocking. Here you have to do IO control socket, and then here you have file control. Sometimes it's a bit nasty, but if you have encapsulated all the bad stuff, then it's quite okay, because now I can just start a TCP server by that's commanding, of course. Now I can just create a TCP server and start the server, and that's it. If you have encapsulated the stuff, then it's quite okay. Then you don't have to look at it anymore. The init library, I guess, will do this for you. All the nasty stuff. External init. Yeah, interesting. Init library. Socket, non-block. Yeah, this is one way to do it. A bunch of if-steps everywhere. The other way is what we are doing in the game. You have one file for each platform. That would be the platform layer, and then the platform layer calls the game main loop. The game shouldn't contain any platform specific code. Yes. Absolutely. That's correct. That are the two ways. Yeah. And it's cool if you have. It's a cool approach, because you see Linux platform client. Okay, and I see that this is only Linux specific code, and here this is only Windows specific code. That's cool. That's a good a cool structure. Strange that I like it. The project directory looks very simple, and it's so powerful. Uh-huh. Ah, well done, well done. I'm not easily convinced, but this is actually very cool. So platform client, here we have the main. Okay, in the platform we have the main. Okay, that's interesting. Okay, Linux platform client main. Mm-hmm. Okay, this stuff looks kind of similar, I think. Okay, it's quite mixed. Uh-huh. Yeah, on Linux it is calls into client CPP. On Windows calls into client. Uh-huh. Okay. So okay, client CPP. Ah, this bug is so annoying. Uh-huh. Both are just opening a window, setting up OpenGL and calling client. Uh-huh. So client is the portable stuff. Update game. Ah, I have seen this function update game. Client and shared are the whole game basically. Mm-hmm. I'm I'm impressed that all the shared, that all this logic, all the different levels are move system, physics movement system. Holy that's hardcore. How many lines does this have? Only 1000. Boah. Mm-hmm. On spawn. How long did it take to make this game? Projectile spawn data make ground shot projectile. Yes, it's compiling. Noch online. noch online is still online. Yes, noch not sure. Maybe a what? A week. A week. Oh God. Noch online. Yes, they managed to. They managed to compile it, and we were playing the game, and the game is awesome. Look at that graphical user interface, and you can you can move around, and there are almost 39 levels, I think. And oh, now I can move. Yes, now I can move. Yeah, that's completely cool. And you can move around, and if you manage to survive this counter in the middle, there is a counter in the middle, and it's multiplayer, so multiple people can connect. And yeah, you're not connected because you closed the server. Now it's open again. Connect to the address in the config. Okay. Okay, what is the server doing? Because okay, it's just Oh no, no, stop. Oh, that was easy. I saw the particles, but I didn't see the player. So the server is sending and managing all the player positions. But it must also be managing the. Not sure what's happening here, to be honest. Lol. Yeah, but yeah, noch online. That's the game, and this is quite cool. 39 completely different levels. You shouldn't be connected, but you seem to be. That's the Linux magic. That's the Linux magic. That's because I've compiled it with G++, not C-lang. No, it's amazing. Noch online, this game took only a week, and has only 2 to 3K lines of code. So I can't imagine how they managed to do it. Actually, it's really funny, especially that you can have a team that is playing together. That's very cool. And the big plus for the Linux port, it's nice. Really nice. That made my day. That was a highlight today. Cool. Yeah, guys. So we didn't start from zero in that week. I already knew how to make an OpenGL window on Linux before. Yes. The OpenGL stuff is quite a lot. If you have the basic stuff for OpenGL, then it's manageable. Yeah. If you can draw stuff and I have the shaders. For example, this shader is But it's very, very cool that you can exchange the shader during runtime. Then you don't have to compile the whole application. This dynamic reloading is very, very smart. Because then you can check out what is happening if I change this and that on the fly. That's cool. That's very nice. Do you have a link to the tower defense you made? The shader uses a cool trick though. It passes all data in a single buffer, so you don't need to care about vertex attributes and things like that. You just copy over a big buffer. Okay. Layout. Okay, a little bit. I understand a little bit. Okay, that's a lerp function. Okay, that's the main, yeah. Vertices, vec2 vertices. Okay, yep, yeah, vertices. 1, 2, 3, 4, 5, 6. Okay. Some stuff I understand, but this is special. I don't understand it. Okay, that's the layout. Yeah, the layout. At least I think it's easier to understand than the conventional vertex buffer setup. Yeah. I don't know. I just have very simple vertex buffers. Yes, completely basic. In shaders, source shader shared. A bunch of those get sent to the shader every frame. That's cool. Wow, that's a structure. The C++ program and the shaders share that struct. Okay. Type def, if def mmap. That's cool. Cool. Shadable. Yeah, I'm doing like that. Yes, there is some. That's so strange. I think I understand what you did. That's the location. I have the location. I can remember only a little bit, but I have a position in the color. Then the output is the V color. That's the input A color. And you're completely using a buffer as transform. As transform. Okay. This is interesting to me. Yeah, that's very interesting how you do this. Because the buffer binding was very, very strange. Oh, the tab is from when this was in POC probably. Yes, this is definitely the C compatibility stuff. Nice. Really, it's the fact that this is running on Linux perfectly. This is very impressive. Cool. I did not expect that you show me such a cool game. Nice. I started with C but quickly went back to C++. I really need my own template for arrays. Yes, I must. Yeah, I coded in C a couple of some years, and it was hard for me to switch to C++. But now I can't imagine to do anything other than also I can't imagine not using C++ because yes, I know what you mean. I also had this period, yeah, when I was switching from C to C++. It was like, as you say, it's still I'm still using a lot of C in my C++ code, but at the beginning it was 80% C and 20% C++, and now it's exchanged 80% C++ and 20% C. And I have found in 2018 I have found my life-changing structure. I made a cool a base class. I'm very proud of it, and that's the reason why I'm making this stream. You can check it out here, and it's a recursive structure. It would be interesting what you would say to the processing class, to this file, because it took me a lot of time to make this class, and it's making things a lot easier for me. I like it a lot. It's the whole structure is very clean because of this class. So yes, and then all the applications we do, make is done in this structure. Yes, no orientation because and abbreviation NOP, like no operation. I'm not coding in an object-oriented way, and I'm not coding in an event-driven way. But it's a recursive structure. It's a recursive structure. Just a short explanation. It's a recursive structure where you have a process function in every file you're using. You have a process function, and this process function is like the main loop. It's like a loop. Like in Arduino, it's the loop function. And no matter at which level you are in your system, you always have this function, and you can create a process at every level, and every process has this function. And then you can do whatever you want step by step in a state machine, and it's quite cool. It allows to create a lot of complex logic. This is what the tower defense looks like. I don't have a proper showcase. It was like. Cool, did you record it? I heard my voice, cool. Holy moly. Yes, that's another leak, yeah. Oh, that's a lot of work. That looks like a lot of work. Cool. Yeah, so I will check out your streams. I will check out your streams definitely in the future. When are you at which times are you streaming? By the way, where are you from? Actually. By the way. You're from Spain. Yeah, that's cool. That's cool. Because then maybe the timings are cool. He's streaming always. Oh, that's cool. I followed you of course, so hopefully I will see you in your streams. Because that... Are you working on this game still, or I guess on the tower defense and this? My times are kind of random, depends on my sleep schedule, which changes all the time. Is the most common. Okay. I will write this down. One moment. I have audience hints. I have to save this for later. TCAP 1. So, okay, so this game is... oh wow, those logs are very organized. Yes, some... more or less. Some logs are better and some are not that good. I like to write down the stuff because I'm old and I forget a lot of stuff. But yeah, some things are quite complicated, and then I need to write down notes and stuff. So it's a habit, and I like it. It's a cool wiki system. Yeah, very cool. Oh, epic one. Oh, that's important. Yes, that's it. I save all the links, GitHub, TCAP one epic online thing. Oh, damn it. So yes, I think this was a very... Hey, what's going on here? Yes, I thought so. Yeah, that's better. This day was very productive. And the game session was very cool. But now I have to go to sleep. See you next time, guys. I think I will not raid anyone today because it's so late. Thank you very much for this cool session. It was very, very, very impressive and cool. Good night and good fight. Oh yeah, or the music kicks in my head. Good night and good fight. See you next time. Next week I'm on vacation, so the next stream is on August 8th. Thanks guys, it was nice because of you. Thank you very much. Very cool.